All right, without wasting much of our time, we're going to start this session, this journey with basic networking. So I believe we may have read so much. We may have read so much about networking, all right? And yeah, so that was the reason I had to share those links. All right, I had to share those links so that you will have a first-hand understanding of what networking is. Be that as it may, I understand that some persons already have a understanding, all right, a fundamental understanding of a networking is. But for the purpose of doubt, it's necessary that we told this path one more time, all right? The purpose of this journey is necessary. We told this path one more time to remind us of things of this nature. All right. So networking, as we all know, even in general terminology, all right, networking is when you interconnect, all right, you interconnect with one another. Okay. Now, but in this context, we are referring to devices, computer. So when computer talk to each other, interconnect with each other, all right, computer, process where computer interconnects, communicates with each other is termed networking. I wouldn't want to go in much detail. Now, types of networks. As you all know, if you are told types of network, so we would say we have a star network, all right? Star network. Let me put this well. We have a star network. We have a ring network. We have a bus, aka some author call it a linear network. All right. Now, this network could also be termed as topology. Topology. All right, take note, guys. Then we also have a mesh. All right, we have a mesh. We have extended star, etc., etc. Right. So if you want to define a star network, is in a situation where you have the setting, the topology, all right, the topology, which is the setting of your devices in a star format. Now, in a star format, we would say you have the center, which is the server as the center. Then you now have every other node, okay, arranged in a star-like position. All right. So where communication goes from the server to the attached nodes, where communication flow from the centralized server, all right, to the respective nodes, right? To the respective nodes. These are the respective nodes. Okay. Centralized server, right? Distributes if communication to both the respective nodes. So this is the star and ring and so on and so forth. All right. Great. Great. All right. So I'm just touching because um we don't we wouldn't be dwelling much on these very basics because we have IP addressing and subnetting. It's a very broad topic, which is very important in the course of this journey. All right. So this is just that. Then ring, as the name implies, it means it's in a circular. Your topology is in a circular fashion. The topology is in a circular fashion. Then bus or linear topology is when you have everything arranged in a serially, all right? Serially. That stands as what linear. Then mesh topology is a topology when all of these are interconnected with each other. They're interconnected, all right? So that's what mesh topology. Now, the next on the next on uh our course content is OSI referencing model. So the OSI is termed as, I'll explain. Sorry. So OSI, which is seen as Open System Interconnects. All right. Now, before I come into before I go into explaining what an OSI is, I would first of all give us a brief story of how came about this term, the OSI referencing model, right? So in those days, we had what we call TCP IP model, all right? TCP, in those days, we had TCP IP model. So the TCP IP model was the first model. Let me put that at the top here. All right. It was the first model. The TCP IP model, it wasn't open. Okay. So it means that every OEM, every manufacturer of networking devices, of computing devices, they have their own style of communication, of communicating. Now, in those days, let's take for instance from IBM. Let's pick an instance from IBM, International Business Machine. International Business Machine. So IBM, we had IBM. Let's add something else. Let's add Sun Microsystem. Sun Microsystem. Okay. So Sun Microsystem. Let's also add let's add one more. Let's just add one more for explanation's sake. Now let's add what should I add, guys? What should I add? So let's add okay, let's just say manufacturer of the, let me see let me just say for instance Microsoft, please. Microsoft. Just Microsoft. Let me just add Microsoft to this list. I just want to illustrate you how came about what OSI model. So in those days, IBM, they were into the manufacture of let's say PC, personal computer. So in personal computer, you have the monitor. So in personal computing, you have the monitor, okay? You have your mouse, you have keyboard. What else? You have your hard disk. You have this. You also have your switch, which is your networking components. You have your routers. This was similar to microsystem, some microsystem as well as Microsoft. So now IBM has their own monitor. IBM has their own mouse, keyboard, hard disks, switches, and routers. Some microsystems, they had their own monitor, mouse, keyboard, hard disks, switches, routers. So we can say, we can just wrap it up and say what? They had their own hardware. They had their own hardware. All right. So these guys, they all had their various hardwares. Okay. They all had their various hardwares. Now, these manufacturers, they all had what? Their various hardwares. Now, the drawback, the challenge they had then was, if you go to the market to get a monitor manufactured by IBM, that monitor, if you bring it home and you have a keyboard or a hard disk or a hardware from Sun Microsystem, that monitor you bought from IBM is not going to work, or was not going to work with the hardware you got from what? Sun Microsystem. The same thing was applicable to what? To Microsoft. So if you buy a hardware, either of this hardware from Microsoft, and you had IBM hardware at home, so any hardware you bought from Microsoft was not going to work with what? With IBM hardware. So then they had what we call hardware incompatibilities. Hardware incompatibilities. So this was a challenge, guys. This was a major challenge. All right, so let me keep it properly. So they had what? Hardware incompatibilities. They all have it. They all had it, sorry. All of these guys, they had it. They had it. They had hardware incompatibilities. So hardware from IBM will not work with hardware from Microsystem. Hardware from Microsystem will not work with hardware from IBM. Now, it means that if you are getting a hardware from IBM, all your sets has to be from IBM. If you're getting a hardware from Microsoft, all your sets of hardware has to come from what? Microsoft. So this was a major challenge until the body then they now came together. They now say this body, it's a standard body, the OSI. They came together and say, okay, that we need to have a standard in this industry. So far, we don't have a standard. Mr. A is doing his own business. Mr. B is doing his own business. Mr. C is doing his business. And we can't talk together. We can't communicate. It doesn't make sense. That it will be necessary that we come together and develop a standard that we are going to work with. Now, all of these guys, we are using what? The TCP IP model. And the TCP IP model, let me copy that. The TCP IP model, I still need to push this guy downward. So in the TCP IP model, we had 4 layers. They had 4 layers. All right. So the first layer was the application layer. The application layer. Sorry. Oh. Now, it was the application layer. Now, the second, oh, sorry, I didn't copy this. The second layer was was called the transport layer. I will check that up. Transport layer. Let me finish. I will check that up, see if I'm correct. Was a transport layer. Then the third layer happens to be the internet, the internet layer. Then the fourth layer became something, is that the physical layer? Physical layer. All right. I will check that up, guys. Now, this was the flow. Let me change this color. Change this color. Repeat that. And then this perfect. All right. So let me do something. Copy this guy. This was right from the top, the fourth layer. So the numbering, the numbering starts from the top, which is layer 4. This layer 4, let me copy that. And this is layer 3. And that is layer 2. And the final is layer 1. All right. Now, they had 4 layers in the TCP IP reference model. The TCP IP reference model. Okay. The TCP IP reference model has this 4 layers: the application layer, the transport layer, the internet layer, and the physical layer. I will check that again. Let's finish. Now, they had this. So everybody was doing its own thing. Now, this body, the OSI, the Open System Interconnect, they came up, they now say, okay, no. Since we already have a model, it will make more sense if we can build on that model. All right, let's build on this model. Okay, let's build on this model. So they started pondering, putting heads together, and finally they came up with a model called the OSI reference model. So their curiosity gave birth to a model called what? The OSI reference model, which till today it is sorry guys, it is the ultimate model. It is open source. It is open source. It is open to all vendor. All right. Now, one of the rules in this model says that if you need to develop, if you need to design a networking system, please design it based on this model. If you need to design a hardware, a networking hardware, please design this hardware according to the rules already in this model. Meaning that going forward, nobody, no OEM, no manufacturer is allowed to do things on its own. Because if you do things on its own, it means that it's only you and your village people is going to buy your hardware. Yes, it's only you and your people and your village people that are going to buy your hardware. In as much as you are out for business, you need to sell, you need to make profits. Please work according to this model. That was how the OSI reference model was given birth to, was born. Now, in this model, we have 7 layers. Like I said, this model was built out of what? Out of the TCP IP referencing model. So they copied everything like this. Let's do this. Let's do it. So they lifted everything. We're going to do a comparison after this. So they lifted everything from the TCP IP reference model, and this is what they did. Now, they had to break the application layer into further 3 layers. Application layer into further 3 layers. Let me go down. Let me bring this guy down. Oh, sorry. Into further 3 layers. And what are those layers? Let's put it out. Yeah. Copy and paste. Bring it here. No, let me do everything like this. Copy and paste. Paste. Now there was application layer. There is a presentation layer, and they also become a session layer. So now you can see that in the OSI reference model, what we had previously on the application layer for the TCP IP has now become 3 layers: application layer, the presentation layer, and the session layer. They now went further. Now say, okay, they now went further. So let me start labeling this down. So this will be 7, and they call this layer 6. They call this layer 5. All right. They now went further and now say, okay, the transport layer will remain as it is. They move it up. They call this guy 4. Now, the internet layer, we are going to change the internet layer from internet layer to a networking layer. Now say, okay, let's change this guy. Let's preserve it. All right. 3. From internet towards network layer. Now, after that, they now say, okay, the physical layer has to be what? Divided into 2 more further layers, like 2 layers. So they now say, okay, let's divide this layer further, copy and paste. Sorry. Oh, sorry, guys. So let's divide this layer into 2 more layers. So let me move this down a bit. Perfect. Now, copy and paste. So let's call this layer 2, and this layer is going to be a data link layer. Then we are going to leave the last layer as what? The physical layer. Hello, guys. So this was their proposition. That going forward, every OEM, every manufacturer must design their system according to what? The OSI reference model. Now, in the application layer, now let's start now talking about each of these layers one after the other, right? Before we do a proper comparison. Now, when you're on the application layer, exposes, okay, or I would say it is at this layer that you make use of your application. This layer, at this layer, all right, the user makes use of application. Example of application could be your web browser. All right, your web browser. All right, you can say your web browser. Now, all right, the web browser. So at this application layer, there are protocols. All right, there are what? Protocols. Okay, at this application layer, we have things like protocols. So protocols are set of rules, guys. Protocols protocols are sets of rules for communicating on the network. All right, a set of rules for communicating on a network, and we have a lot of protocols at this application layer. We have things like HTTP, we have things like HTTPS, we have things like IMAP, we have DNS, we have POP, UP3, etc., etc. We have FTP. We have FTP. We're going to talk about all of these more when we come towards this section, which is services and port numbers. So just want to keep it on the low. And I expect that you've already read, all right? But I'm still going to talk about them. So these are the protocols that you have that runs on what? The application layer. Okay. Right. So this layer, the user makes use of what? Application. That's why it's termed as what? Application layer. And kind of application is a web browser, right? Now, after that layer, control is passed onto what? The presentation layer. Now, for instance, now, I need to visit www.google.com. So I'm going to open my web browser. My web browser is the application. All right. Now, after that, control is passed towards the presentation layer. So now the presentation layer will not tell me in what format. Let's do this. The presentation layer tells the user what format is he going to access the web, in what format. So the format that the presentation layer is going to present my web communication is via HTML. All right, that's the format. The www, the World Wide Web, uses what? HTML. At some point, it also uses XML. Right? So in what format? We have things like HTML, we have XML, different formats. All right. So this is what the format, the presentation. How is it going to present your request? That is handled at what? The presentation layer. Now the session layer, after the web has been rendered, all right, has been presented in the specific format that the www understands, or whatever application understands. Control is passed toward the session. Now there must be a session that has to be created. A session has to be what? Has to be created. So that's why most of the time when you go to some web browser, you see that you always see cookies. All right. So cookies will always initiate, will always save your session. After you're done browsing that website, once you close the website, your session ends. So that's what the session layer does. The session layer opens the section. All right. Now, what happens here is the session layer opens the session for what? Communication. For communication to what? To commence. For communication to commence. Commence. All right. That's what happens at what? The session layer. Now, after communication has opened, control is now passed to what? The transport layer. So here, the transport layer, we have two sets of protocols. So now, the transport layer is responsible for transporting your data. All right. This layer is responsible for what? for transporting, all right, your data, all right, from the what? The destination to the source. Now, this layer, is it called data or data? Just curious. Is it called data or data? Ayobami.
I want to know if it's called data or data. So
It's our language now. You know, we are from here, all right?
it's a joke.
Yes, yes. No, no, all right. It's English, guy. It's just English. We call it data, all right? It's data, all right? But when we now start putting in phonetics, right? So we in this part of the world, we don't have that phonetics. Right, so that's why. But if you want to go by proper pronunciation, okay, it's data. All right, it's data. All right. So yeah. So thank you for that. Now this layer is responsible for transporting your data, all right, your data from the destination, which is at this time is destination, to the source. Now this layer has two major protocols. It has two major protocols, all right, which are one, TCP, and the other is what? UDP. Now TCP says what? TCP is transport communication protocol, all right. Now the UDP is user datagram protocol, all right, user datagram protocol. Now it is at this layer also creates segmentations, all right. We wouldn't be going into much detail, right? So you're just giving us top level, all right, top level information of what these layers are all about. Now, what will happen here is, like we said, this layer has two sets of protocols, the TCP and the UDP. So there are protocols that are classified under what? TCP. And there are protocols that are classified as what? UDP. Okay? UDP. Should I want to do this? 1 second, guys. Let me see. How are we going to get this again? Three-way handshake. Three-way handshake. All right. All right. All right. Please remind me to come back to this layer 4, transport layer, to talk about TCP and UDP. All right. Need to talk about their differences. Because it's very important, because you'll be asked countless times in an interview. Need to talk about their differences. Okay, talk about their differences. So let me push this down, push it down a bit. Perfect. Okay. Now there are protocols that are classified as TCP and some are classified as UDP. So let me just put that down. So I hope you've read. So we have HTTP, we have SSH, we have TCP. Oh, sorry, I said TCP now. TLS, we have SSL, we have HTTPS, we have, they are a lot. We are going to explain why these guys are called TCP and why the others are called UDP. We also have FTP. FTP, there are two different versions of FTP. all right? Version number 20 and version number 21. So version number 21 runs as TCP, but the other runs as UDP. We're going to explain all of that. Now, there are other protocols that runs as well, that are classified as what? UDP. Example is DNS. What else? Then all those are VoIP. Those are VoIP, voice over IP, voice over IP, VoIP protocols. All right. These protocols runs as what? UDP. All right. Great. Now the network layer. So the network layer, this is where IP addressing operates. This layer is where IP addressing operates, right? So this is the layer that talks about IP addressing. This layer talks about IP addressing, internet protocol, all right? Internet protocol addressing, right? IP address. Now, going further, we have the next layer, which is what? The data link layer. So this layer, on this layer, we have devices like the switches and hubs. They operate in this what? Layer. All right. And other data link protocols. There are a lot of data link protocols. If you've taken your time to read and you got to this stage, all right, reading the functionality of each of these layers, if you expand it further, there are other data link layers, there are other protocols, there are lots of features that these layers possesses. All right, so great. Then one again, now the router, let me come back to the network layer. Your router operates, okay, on this layer. All right, your router operates here. All right, great, because your router takes what? IP address. Your switches operate at the data link layer, because your switches, you assign them what? MAC address. So what's the MAC address? The MAC address is termed as a MAC address. It's termed as a media access something. Is it control? Something, I'm not really sure. Media access control. But try and look it up. All right. So that's the data link layer. Then the physical layer. This is the layer that we see whenever we go to a cyber cafe. When you go to a cyber cafe, all right, your cables, your networking cables, your RJ45 cables, your Cat5, your Cat11, they operate at this level. So this is what you see at the physical layer. The physical layer is what you see with your physical eyes. So that's why it is termed as what? The physical layer. So this layer presents what you see with your physical eyes. All right, your physical eyes, what you see around, right? Things like networking cables, you name them. All right, you name them. So this is the whole flow of the OSI referencing model, right? The OSI referencing model. Okay. Now, if we need to do a comparison with what we have from copy and paste with TCP IP, you can see that, yes, let me keep it this way. Move this guy a bit. You can see a proper, yes. Now let me demarcate this guys so I can demarcate from here. So yeah, so the application layer on the TCP IP side is equivalent to 3 layers on the OSI referencing model side. So same thing happens to the transport layer. The transport layer it remains the way it is. And the internet layer on the TCP side turns to be a networking layer on the OSI referencing model, right? Then the physical layer has 2 additional layers, which are the data link layer and the physical layer. So guys, this is what we call was the OSI referencing model. Now, let's now drill deeper, all right, at this transport layer, which is we want to talk about the TCP and the UDP, because you always have this in an interview. What's the difference between a TCP protocol and a UDP protocol? What's the difference between a TCP protocol and a UDP protocol? TCP and UDP. So let's get started. Let's get started. Now, a TCP let me use TCP. A TCP protocol undergoes a 3-way handshake. Now we're talking about the difference between, right, TCP and what UDP, right? Now TCP goes through a 3-way handshake, while UDP does not go through a 3-way handshake. Now we're going to explain to us what a 3-way handshake is. Now, before communication has to commence on TCP, TCP has to go through a 3-way handshake. All right. Now let's do the illustration. Let's say this is my client, and let me call this, sorry, copy this guy, copy and paste. All right, so let me change and call this server. All right, so here is my client, here is my client, and here is my server. All right, so now for TCP, this is for TCP, this is for what? TCP. So for TCP, like we said, it goes towards through the 3-way handshake. Now, for TCP, the client will first of all send a sync packet. It is called a sync packet. Let's come here. SYN. It sends a sync packet towards to the server. That's CO. I would like us to communicate. Okay, let me just say client or source. Don't too small. All right, so this is better now. Client or source, and this is server or destination. All right. Destination. Now, the client or source will send a sync packet to the destination that, see, bros, I want us to communicate. All right. Now the client will wait in TCPO. The client is going to wait for a response from the destination server. So if there's no response from the destination server, the client will continue to send a sync packet. It will continue to send a sync, copy and paste. You send a second sync packet that I didn't get the first response. I didn't get your response. Please, I'm sending another response. It will keep sending that response until it times out. It will now tell you that it times out. That's why when you see in most when you're doing some networking, whatever, you're trying to connect to a source. You tell that communication or request time or response timeout, because the destination is not responding. The source is sending a request because you are using what, a TCP protocol. You could be using a HTTP, or you are using a HTTPS or SSH or whatever protocol that runs on what, TCP. Now, when you use that, it's expecting a response, and whenever there's no response, it will just time out. You tell that timeout, destination unresponsive. Now, let's now say, for instance, there's a response. So the client will always wait for a response. Now, let me remove this guy. I just explained that response part. Let me keep it somewhere so that you understand. If the destination does not respond, it's going to time out. Now, let's now say the destination now responded. So this guy will wait. The source will wait for what? The destination to respond. And the destination will respond with two kinds of packets. It's going to respond with an acknowledgement and a sync packet. Take note, guys. Oh, take note. This thing, if you meet someone who has background in networking, they will always ask you this question: TCP and UDP, what's the difference? All right. And if you now mention TCP goes through the three-way handshake, UDP does not go through the three-way handshake, you now underline that handshake. What is that three-way handshake? Can you explain for me the TCP three-way handshake? You have to explain this process. The source and the destination. The source sends a sync packet and wait for the destination to respond. And when the destination will respond, the destination sends an acknowledgement and a sync packet. Then finally, the source will now send an acknowledgement. That's CO. Now let me explain what that acknowledgement is. Let me copy this, copy this, copy and paste. Copy and paste. All right. Now, the first sync packet states that, please, I want us to talk. I want us to start communicating. Now, the destination will receive what? The sync packet. If you look at it, this guy wants to synchronize. That's what that sync means. Synchronize. You want to synchronize with me so I can start communicating. Okay, I'm available. Now, this guy is going to respond. He's going to acknowledge your own synchronized packet that you sent. Is acknowledging that, CO, I receive your sync packet for us to communicate. I receive it very well. Quite all right. Then me, I also will send my sync packet along with my own acknowledgement. That, see, I also want us to what? Communicate. Then the source would now acknowledge that, see, I also receive your sync packet. Then communication can now start going through back and forth. Communication will now start going through what? Back and forth. All right. At this point, communication has been what? Established. Take note, guys. Take notes. Now, that was what the three-way handshake. The UDP does not go through the three-way handshake. In the case of a UDP, let's show us what a UDP does. So in the case of UDP just keep sending sync packets. It just keeps sending sync packets. It doesn't care if the packet gets to the destination or not. It keeps sending. It just keeps sending infinity. Infinity. It will keep sending. It keeps sending. It keeps sending. It doesn't what? It doesn't care if the destination receives the packet or not, or if the packet gets the destination or not. Now let's continue the differences. On TCP, packets, we call packet as data, are gained. All right, packets are gained. Packets don't get dropped. All right, or can say packets don't get dropped. Right, packet don't drop. When I say packet don't drop, the communication is always entrusted. Right, it's always trusted. Now on TCP, packets are gained. Packets are gained, or packets don't get dropped. While on UDP, packets get lost easily, right? While on UDP, packets get lost easily, right? Because as this thing is now, I don't know if my packets was successful. My packet got to the destination successfully, all right? Because there's no response. I didn't get any response from the destination. I didn't get any acknowledgement, all right? There was no acknowledgement, all right? So, and TCP is slower, while UDP is faster. Now let's explain. Now, why TCP is slower? TCP is slow because TCP will have to wait for a response. So why TCP is waiting for that one packet it has sent, all right? UDP has already sent like 10. So UDP does not wait for a response. TCP will always wait for a response, all right? UDP does not wait for a response. So UDP will keep sending packets, okay? Now, TCP is reliable, all right? While UDP is not reliable. Now, when we say TCP is reliable, it means you always get an acknowledgement. It's a reliable packet, all right? When you send a request, there'll always be a follow-up response, all right? Yes, so that's a reliable communication. But UDP is not reliable because once you send a sync packet, there's always no response. So guys, that is the difference, all right? These are the few differences you need to just say in the interview about TCP and UDP, all right? So that's that. So now, next on the list is services and port numbers, right? There are a lot of port numbers, and all these port numbers, they are already assigned, right, to protocols, which is the services. Now, we have three kinds of port numbers: ports, services, and port numbers. All right. All right. So services and port numbers. All right. Now, in the world of networking, okay, we have assigned port numbers. We also have unassigned port numbers. Then we have reserved port numbers. So now, assigned port numbers, as the name implies, they've already been assigned to services. They've already been assigned to services. Let's come here. So assigned port numbers, let me call it APN. All right, assigned port numbers. These have already been assigned to what? To known, thank you, that's the keyword. That's a keyword. To known services. To known services, example, e.g., we have things like HTTP, which uses what? Port 80. HTTP uses port 80. Okay. HTTP uses port 80. We have HTTPS, which uses port 443. Okay. SSH, which uses what? Port 22. FTP, which uses port 21. Telnet, which uses port 23, etc., etc. So now it means that there's a service that runs on port 80, a known service that runs on port 80. So if I'm developing my application and I decide to go and give my application, I tell my application that my application is going to use port 80, and I give it a different name that is not HTTP, my brother, it's going to throw up an error that that port is an assigned port. You're going to have an error of this port is already allocated. All right. So you don't have to use that port. All right. You don't have to. It's a PIPA. There's an organization that is responsible for assigning port numbers. Let me look at APIPA. APIPA. Or APIPA is IP address. APIPA stands for Automatic Private IP. Okay, this is APIPA. Which port numbers? Port numbers assignments. Let me see which body port numbers. There's a body. Wait, somebody have said something here. Ayana, thank you. All right. Yes, thank you for that. All right. Thank you. All right. So service number and transport protocol number registry. Okay. So internet is called Internet Assigned Numbers Authority. So for those that are not aware, so please read up this guy. Okay. Read up this guy. You have different, you can see them here. There are different port numbers. You can see their description. If they are reserved, you see that they are reserved. If they are already assigned, you see assigned. Assignee, okay. Okay, the person who assigns it in the organization. And so these are the ports. All right, SSH, telnet, right, etc. So guy, we can see unassigned somewhere here. Can see unassigned, it has not been assigned. There's no service. Can see port 26 now. Port 26 does not have any service at all. So it means that if you want to develop an application and assign it a port number 26, it means that your application is going to communicate via port 26. All right. So you can give it any name because it has not been assigned. So anybody can use port 26 in this planet. It is not universal. It is only unique to your own application. It's only unique to your own application. So me, I could be in US, I'm developing an application, and I'm assigning my application what? Port 26. You could be in Germany, and you're developing a different application, and you assign that application port 26. So there will be no complaint because it is unassigned by this IANA body. All right. So let me share this, guys. So you take your time and go through that. Stop share. Go through that a bit. Let me share that quickly. Where's the group? Where's the group? Okay. So you take notes. That's it. So I've just shared that. I'll just share it. It will go on this. All right. Okay. So let's move on, guys. Let's move on. Okay. So this is what you get. Now you also have you also have you also have you also have unassigned port numbers. Like I just mentioned, they've not been what? Assigned. Then you have reserved port numbers. They are used, they are reserved, they are kept for testing purposes. Testing what? Purposes. So that's that about what? Services and port numbers. Then IP addressing. IP addressing. Now, when we say IP addressing, an IP address is a number that is used to identify devices on a network. An IP address is a unique number that is used to what? Identify devices, to identify network devices on devices on the network, to identify devices on the network. That's what an IP address. Because you could be thrown off balance. You could be asked in an interview something you're not expecting. Some of you just say, what's an IP address? IP address. IP address. Just start asking yourself the question. IP address. IP address. IP. Now, let's explain. Let's go detail now. Let's bring this explanation to what we already know. If you walk on a street, every street, every house, every building on the street has a number. Every building on the street has a number. All right. And to identify a particular building, they assign it what? A particular number. So on the street, no two buildings can be assigned the same number. Number 14. Let's say, for instance, number 14. Building A, building B cannot be assigned number 14. In a situation where there is a two building being assigned the same number, there's bound to be confusion. All right. So for we to avoid that sort of confusion, we assign every building must have a unique number. So that's why when you're filling a form, they ask for your address because they need to know who you are. They need to identify you. So if they need to look for you, they'll trace you to your address. The address you provided on the form, they will trace you to your address. All right? Number 16 dash this Alakija. So you're easily traceable. The same thing is applicable to devices on the network. For you to trace a network, you have to look up the IP address. This IP address, where is it coming from? This IP address, which device uses this IP address? That is IP addressing. That's the idea behind what? IP address. Now we are being told that there are different kinds of, they call it classes. Class of IP address, right? So we are told that we have class A. We're also told we have class B. We are told we have class C. We went further and said we have class D. And we have class E. Right? Now, let's talk about these classes with their characteristics. All right? Characteristics. So if you have read, all you've read will now start replaying before your eyes. All right? All you have read will start replaying. That's why I needed to share those things with us. So I'll go home, read. So when you come to the class, it's like it's a refresher. All right. So now class A, let's start with their properties. Let's start with the properties. So for class A, okay. Before that, let's still talk about some of these feature of IP addressing. All right. An IP address is a dotted decimal. All right. It's a dotted decimal. Okay, an IP address is represented in a dotted decimal format. That's the right English coining. An IP address is represented in a dotted decimal format. So when we say dotted decimal, what do we mean? Brackets. So we can say x dot x, that means capital X, x dot x dot x dot x. Now we are on some few characteristics. Let me call it characteristics, features. Let me call it features of an IP address. An IP address is represented in a dotted decimal format. An IP address is 32-bit long. So when we say 32-bit long, it means that each of these dotted decimal, this decimal is what? Is 8 bits. All right. Now let's come. Where are you? Each of these dotted decimal, meaning that each of the dotted decimal is 8 bits. Each is 8 bits. That's why it is 32 bits long. An IP address has 5 classes. Class A, class B, up to class E. What else? What else with an IP address? All right. Maybe other features. Let's move further. Now let's come back to this guy now. Now, features of class A. features of class A. Class A IP has class A IP is represented as N.H.H.H, where N is network and H is host. Okay, let me call it like this. Where host bits, let's say host bits and network bits. All right, where N is network bits and H is host bits. Let's still continue. Class A has 8 network bits and 24 hosts bits. That's why it is represented as N.H.H. N takes 8 bits. The 3H, 8 times 3 is 24. 24. All right? Great. Class A has a total of on class A, all right. On class A, you can create a total of 256 networks. How come about 256 network? Here's the formula: 2 raised to the power of n. 2 raised to the power of n, where n is what? 8. When n is equal to 8, it implies that the total number of network will be 2 raised to the power of what? 8, which will give us what? 256. Guys, take note to now OT, now OT. All right. I'm taking my time. I'm taking my time because these things are things you need to know. So the basics. On class A, you can create a total of that I don't know, 2 raised to power, let me call it XXXXX hosts. You can do the maths. Let's do the maths. Calculator. 2 raised to the power of, do I have that kind of calculator? I don't have that calculator here. It's not that complex. My calculator is not complex. All right. 2 raised to the power of 24. Now see, on class A, you can create a total of, can someone just do 2 raised to the power of 24? Let me see something. Google. 2 raised to the power of 24. You should get now 16 million we are getting undo 16 million 16 million. Sorry, it should be here. Total of 60,777,216 hosts. 16 hosts. So minus 2, it will be 214. I'm coming. Minus 2, I'll talk about y minus 2. Now, the formula is 2 raised to the power of n minus h. Sorry, h minus 2, because it's the host bit. H minus 2 when h is 24. It implies that 2 raised to power 24 minus 2 is going to give us what? 16,777,214. Now, that 2, one among the 2 represents, okay, let's put it somewhere here. The 2, the minus 2 represents the network address and the what? Broadcast address. So you need to minus the network address and the broadcast address. A network address identifies the network. A network address, this is a note. A network address identifies a network, while, okay, let me still come down here. A broadcast address, as the name implies, is used for sending broadcast messages. That is the purpose. That is the purpose of a broadcast address. All right. Great. What else? Class A is presented as these. Class B. The default subnet mask of class A is 255.0.0.0. 255.0.0.0. Why is it 255? Because we have the notation as n.h.h.h, where in the context of subnet mask, all right, when in the context of subnet mask, the subnet mask defines a network. Guys, listen, the subnet mask defines the network, and it uses the network bits and uses network bits. That is why, all right, for class A has only one network bit. So that network bit is filled up. Now, when we, let's do it on that note. Come down. Note N dot H dot H dot H. It means that the N bits, this is the network bits, is filled up. It means I have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Dot 0, dot 0, dot 0. Which is interpreted as 255.0.0.0. We're going to explain how come about that digits 255. Now, the subnet mask, you could be asked in an interview, what is subnet mask? A subnet mask is a part of an IP that defines the network. It's part of an IP that defines the network. A subnet mask defines a network. That's all. So if your subnet mask is 255.0.0.0, what class of IP address is that? It's class A. Simple. It's class A. So I'm listing these features so that we would know how to separate these things, because we are going to see a lot of IP addresses. So your ability to differentiate them will help you. That is why we needed to go through this route. It's very important. I will explain why that guy is 255. IP address. Okay, come. This next feature. An IP address is based on binary. An IP address is based on binary, which is base 2. All right? In the numbering system, all right, base 1 is called unary. Unary. Base 2 is called binary. Base 3 is called something. Base 4 is called quad. Quad. Base 5 is called pent. Base 6 is called hex. Hex. Base 7 is called hep. Base 8 is called oct. Eh? Because we need these guys. In the let me just list it, guys. Sorry for that's me, because everything here is just pouring from my head. It's what I'm remembering. I'm bringing up. So in the numbering system, all right. So we have one as unary, we have 2 as binary, we have 3. I forget. I have 3. No. Is it ternary? Ternary. I know they sure. I know they sure. I'm put an asterisk. Let us check. I know they sure. 4 is quad. 5 is pent. 6 is hex. 7 is sept. Septa. 8 is oct. Octa. 9 is nano. Nano. Then 10 is deca. This is decimal. All right. Great. In the numbering system. Now, IP is based on, is converted from base 10. You can convert it between base 10 and base 2. So base 10, we term it as deca, which is decimal. Whole number. Deca, that's base 10. To convert to base 2, change it from decimal to binary. So binary is what? zeros and ones. So an IP address is based on base 2, which is represented in what? Zeros and what? Ones. Zeros and ones. We are continuing, guys. I will explain how we came about this ones. Now, the range of class A IP address is from 0 to 126. So it means that I can have something like 0.0.0.0. That's class A. Once you see in class A, you get things like 1.0.0, this. Anything from 0 to 126 to 126 dot. The last octet, the last value in that octet, the last value, 255.255.255. So 255, an IP address is 256 bits, is 256, all right, is 256. An IP address is 256. Each octet, all right, each decimal is an octet. Octet means 8 bits. Octet means 8. All right, no wala. You get the recording. No wala, you get the recording. All right. Okay. Now, each decimal is an octet. And an octet is what? 8 bits. Is 8 bits. Sorry. Is 8 bits. Okay? We're almost through. I just need to, what I'll do, I'll just copy and paste all of these into the various classes. So that's why I needed to take my time and talk about this very properly. All right. The range of class A IP address is from 0 to 126, right? So it means I can get from 0.0.0.0 until 1.126.255.255.255. So now the value of an IP address is from 0 to 255. 0 to what? 255, which will give us what? 256. But we are including 0. So if you count from 0 to 255 to give you what? 256. 0 is 1, 1 is 1, 1 is 2, 2 is 3, 3 is 4, just like that. Count to 255 to give us what? 256. All right. So the moment these octets are filled up, it will now spill. It will spill over. Sorry, in between we have something called a loop back. I didn't mention that. All right. Okay. So it will now spill into an address called a loopback address. And that loopback address starts from 127. The loopback LP address ranges from 127. It takes 127 all through 127. So you can have things like from 127.0.0 127.1, 127.0.0.2, up till 127.255.255.255. So the addresses in this range is known as a loop back address. Now, from here now, look at guys now. Once this last octet gets filled up till 255, there's nowhere that you can add any other value. So it's going to pop and spill into the next address. So the next address will now become what? 127. When 127 gets filled, the last octet, 255, it will spill into 128. We are coming there, guys. All right? So that's what the loop back address. Then what is a loop back address and what are they used for? Let's look at that. The loop back address is used for internal testing. They are used to determine, let's comment here. They are used to determine if a device is working, if a device has a network access, if a device has a network access. That's what that IP address is used for. That's why most of your time, when you see local this thing, you see they call it local host. Is also known as AKA local host. So local host is the DNS name, is the domain name. The IP address for local host is 127.0.0.1. That's a local host. That's why if you come here, if I open my terminal and if I say if config, I'll see all my interfaces. All right, my IP address, my interfaces, and the IP address. I'll now see my local host is identified as LO, local host. Then you see the internet, the iNetwork. The network address is what? 127.0.0.0. All right, sorry, .1. Okay, so that's it. So now I think we are good. Now what I will do now is I'll just copy and paste everything from class A to class B. So in here, so let me just copy this features, copy, come over to class B, paste that. Now class B IP address is represented as n.n.h.h. Now class B has 16 network bits and 16 host bits. Class B, you can create a total of 2 raised to power n, which is 2 raised to power 16, which you can always do here. 2 raised to power 16, we have like 35,000 something. 65,536. Where is it? 65,536 networks, right? Where n is 16. 2 raised to power 16 gives you 65,000 waiting 536. Now on class B, you can create a total of the same thing, 65,534. All right, 534 hosts, because we are minusing -2, 16 bits. So 16 minus 2 is going to give us 65536. All right. On class B, okay, a network address identifies a network. Sorry, a subnet mark. So yeah, okay. Oh, sorry, a network address. Okay, and a broker address. Okay. Subnet max. This default subnet max of class B is 255.0, 255.255.0.0. So n.n.h.h. All right. Now this has to be like this. Then this will be 1, 2, 3, 4, 5, 6, 7, 8. And this will also be 255. All right, great. And the range of class B is from 128 to 191. So I can have something from 128.0.0.1 up to 191.255.255.255. Okay, yeah, that's all. Then let's copy the same thing, copy and paste it on class C. All right, so you can see class C IP address is represented as n.n.h. All right, great. Now class C has 24 network bits and 8 host bits. So on class C, you can create a total of 16 million. Yeah, 16 million. What was 16 million something again? 16 million, 16 million 777 and 216 networks. No. Yeah. Networks, sorry. Networks, yeah. Trace to power n, where n is 24. All right. So 2 raised to power what? 24. So we're getting 16,777 and 216. All right. On class B, you can create a total of 254 hosts. 254 hosts. We have two raised to power h minus 2, where h is 8. So 2 raised to power 8 is 256. So 256 minus 2, we're going to get 254. 254. All right. Okay. Same thing. Then the default subnet mask for class C is 255.255.255.0. Okay. So here we're going to have n.h. So it has to be 1, 2, 3, 4, 5, 6, 7, 8. So it has to be 255, right? Now the range of class C IP address is from 192 to 224, thereabout 224 something, abi 224. I will check later. All right. So we can have 192.0.192. All right. It flows like that. 192.168.168, just like that. That's how class C gets started. All right. So 224, 224.255.255.255.0. Okay, great. Now class D and class E, these two addresses are used for testing purposes. One is multicasting, and the other is broadcasting. So this guy is multicasting, multicast, which is class D, and class E, broadcasting. All right. So these guys are used for testing purposes. So far, so good, guys. So this is all about IP addressing. IP addressing. So what do we have? Are we through? Now, subnetting. Subnetting, as the name implies, is a process of dividing network. When you have a network address, now you want to divide that network into multiple addresses. Into multiple addresses, you are going to what? Create a subnet, right? We're going to create a subnet. That is subnetting. So far, so good, guys. At this juncture, we want to call today's session to a close. So this is in a brief about basic networking. Basic networking. All right. So before we draw the curtain close, we want to open the room for questioning. I think the wrong finish. We want to open the room for questioning. But where there's no question, we can call it a day. So you try, you have from tomorrow, you have from 10 a.m. till 2 p.m. All right. 10 a.m. to 2 p.m. to go through this recording, to have a first-hand understanding. Okay. All right. So yeah, guys, any query before we call it a day? All right. All right. All right. All right, guys. All right. So, guys, thank you so much. Thank you for the time. And it was nice having you for the session. We are just getting started. All right. We're just getting what started. All right. We'll review the session again and revert with questions for tomorrow. No wala. Okay. So when we meet tomorrow, we are starting off with cloud computing. Right. We shall go straight into AWS. All right. So this basic networking, the idea in this basic networking is going to lead us into what? VPC. So the first service we shall be talking about tomorrow is VPC. Until then, I'll say a good night, guys, and a bye-bye. Stop my recording.